Hello everyone, welcome to the start of a new topic. We are revisiting now probability, and especially once we get to year 9, the content that we're doing today, this is where our probability starts evolving. It starts getting a little bit trickier. So I've skipped the initial revision chapters that you'll see in most of your textbooks where we cover year 7 and year 8 probability. So in this video series, I'm just going to be talking about purely year 9 content. So let's jump straight in and look at these two new types of ways of representing information which are going to allow us to do these probability questions. So we are looking today at Venn diagrams as well as two-way tables. Now the purpose of these is to help organize outcomes into different categories. Okay, now, if you remember when we talked previously about probability, we looked at the idea of outcomes. So take a dice roll, you can get 6 possible outcomes. Because you have a 6-sided die, you can roll a 1, 2, 3, 4, 5, or 6. And any other type of probability thing, a coin flip, a deck of cards, any of these examples we looked at in the previous video series, they looked at one type of area, one outcome. So we looked at a dice roll, so we had a bunch of different outcomes there, but we're going to get one of these possible faces here. But now we are working with multiple bits of information. We are working with different categories of information here. Now this is going to be clear when we go into some questions. So let's just jump straight in here. Now let's say that we had 30 people surveyed about their favorite sport. So we have two different groups of people, I should say. So from these people, 21 like basketball, and we have 12 that like tennis. But from these pieces of information, we have that also 7 like both, and 4 like neither. So we have a lot of different pieces of information, and we want to organize this in some type of way. Now, the first way we are going to do this is through a Venn diagram. So I'm going to draw a nice big one here. You may have seen something like this before, but if not, that is okay because we're going to cover all of this today. Now, let's actually break down some of this information, and as we're doing it, right at the start here, I'm going to deliberately make a mistake that I notice a lot of students make, and then we're going to break something like this down. So what students typically do is they organize this into groups. So we have, okay, this one will say that this circle represents basketball, this circle represents tennis, and this middle section, that's going to represent both, and outside here, that's going to represent neither. So what students typically do is they just read off here and plug all these numbers right into our Venn diagram. So they go, okay, 21 like basketball, 12 like tennis, 7 like both, 7 like both, and 4 like neither. But Once we organize our information like this, there is a little bit of a discrepancy, because if we were to add all these numbers together, even just adding 21 and 12, we're going to get 33 here, which is way bigger than the 30 people surveyed. So something has gone wrong here. And believe it or not, this actually happens quite often when people start working with these Venn diagrams. We have to consider this overlapping section here. That's 7 like both. Here we have an overlap of these two groups. So what that means, well, first of all, we can leave the 4 in here. 4 like neither, that's okay. But in this group of 7, these 7 people that like both belong to both the 21 as well as the 12. So that means 7 out of the 12 people that like tennis also like basketball. Similarly, 7 out of the 21 people that like basketball also like tennis. So what we have to do when we organize this into our little sections here, we have to take into account this overlap. So that means that the people who just like basketball, so that is going to be this section here, not including the overlap. This guy here is going to be people who just like basketball and don't like tennis. Similarly, this section here, this is made up of people who just like tennis but not basketball. Only these 7 in the middle like both. They like tennis and basketball. So that means that if I wanted to find out how many people from the 21 in total that like basketball who only like basketball, I have to subtract my 7 from these to find out which ones only like basketball. So this section here is going to be 21 minus 7 to give me only basketball. Because remember, 7 of these people that like basketball also like tennis. Now, when I subtract 21 from 7, I get 14. So I can rub this. Actually, let's just leave it there for working out purposes. And now in my right circle, I'm looking at the section here, as people that just like tennis. So I have to take away the 7 that like tennis and basketball. So what I'm going to do is I'm going to do 12 minus 7, and that's going to give me 5. Now let's consider this Venn diagram now, because now it's important to distinguish between these different spaces on the Venn diagram. Now, let's look at what we have here. I have that 14 people just like basketball. And along with those 14 people, 7 also like basketball, but they like tennis too. So the total space here in just my basketball circle is 14 plus 7, which gives me my 21 up here. Similarly, in this circle on the right hand side, 5 people just like tennis and 7 people like tennis but also like basketball. So those two together, 5 and 7, this entire space makes up my 12. So now I don't have any discrepancies here. And if I add these together, adding 14, 7, 5, and 4, 14 plus 4 plus 7 plus 5 that gives me 14 plus 4 gives me 18, and then 7 plus 5 gives me 12, so I get 30. I get my original amount of people. So this is how we can think about just constructing this Venn diagram in the first place, because we have to consider the spaces in this Venn diagram. We are working with communicating a bunch of different outcomes and different types of information. So when we say people liking both, they belong in both as part of this category as well as this category. And now that we've set this up correctly, we can actually work through some questions. So let's just quickly summarize the information that we have here. So part A, we're asked how many people like basketball or tennis. Okay. So, what space is this considering? So basketball or tennis, what this or means is it means that it can be basketball, tennis, or both. So I'm looking at the entire space here. Because the people that like both still like basketball or tennis. So we belong, this wording of or talks about my entire space on my Venn diagram. So the people that like basketball or tennis is going to be 14 that like only basketball, the 7 that like both, and the 5 that like only tennis. So I'm going to get 14 plus 7 plus 5, which gives me 26. Okay, so in part 2 of this question, so this is part 1, this is part 2. Here we are asked how many people do not like tennis. All right. So we are looking now at everything except for this section here. Because these, considering the spaces again, my both, they're still classified as people that like tennis. And my 5 are classified as people that only like tennis. So we're considering the people that like only basketball to answer this question, as well as those that like neither. So my people that don't like tennis is going to be everything except for the middle, the overlapping section, as well as the tennis section. So that's just going to be 14 plus 4, which gives me 18. Another way we could have done it is to take my total people and just subtract the sum of these two. That would have given me 30 minus 12, which gives me 18 once again. And we are now in the final section. We're asked how many people like only tennis. But we've already answered that because we have this 5 here. As long as we make a Venn diagram really nicely right off the bat, the questions become a lot easier. We can just read off our really nice Venn diagram. So we're actually just going to skip that question and go straight into section B. So now we are asked if one of the 30 people was randomly selected, we want to find first the probability that they like basketball. Let me just write this as B to save time. Probability of liking basketball and tennis. So this is where we need to distinguish. A simple change in words makes a massive difference. This and or give very different meanings. Remember, our or included everything. Basketball or tennis or both. But our and here, basketball and tennis, we are only considering those that like both. This overlapping section here. So, remember when we come up with probabilities and write these out, we are looking at the probability or the number of favored outcomes. So this is the outcomes. This is the people that like both, as well over the, total outcomes. That's how we lay out all of our probabilities as fractions here. So our total outcomes, our total amount of people there are, is 30. And the ones we are looking at for this particular question, our favored outcomes, is going to be the 7, the people that like tennis and basketball. Now in the second part here, we are asked the probability that people like neither. So we look back to our nicely drawn Venn diagram and we consider those that like neither. So we have 4 over the 30 possible people we have. Now I hope you guys can see here that the hardest part really is the start, just drawing our Venn diagram and having it make sense. Once we have everything there, we can just read off the answers quite easily. It's just a matter of locating our information, our relevant information on the Venn diagram. So this thing here can just simplify to 2 over 15. And our last part, we want the probability, that they like only basketball. So, what bit am I looking at? Am I looking at this? Well, no, I'm not, because the section here is basketball and tennis. So I'm looking at only basketball. So only these 14 people we have here. So that gives me 14 over 30, and that will simplify to 7 over 15. So once we have a nice Venn diagram, as long as the information is there, the relevant information, we are going to be okay. Now, with this second example, let's use this. Let's, in doing this, have a look at the two-way table. Now, the two-way table it communicates the very similar parts of our Venn diagram. These are just 2 different ways of conveying this information about multiple outcomes. So let's just read the question first. At a car yard, 24 cars are tested for fuel economy. So let's underline all the important bits too. So 24 cars in total are tested. 18 of the cars run on petrol, 8 cars run on gas, and 3 cars run on both petrol and gas. So, in designing a two-way table, we want to similarly get an overlapping type of thing happening, but it's going to be a little bit different. It's going to look slightly different here. Now, let's just make this as big as we possibly can. So, this two-way table is going to communicate some information for us. It's going to tell us the people that have cars on petrol, and it has the gas here. It has a section where, as we've considered petrol, we want to consider also the people that don't have petrol, so not petrol. Because remember, sometimes we can have an overlap. So we need to write as much information as we can here. We have gas here, but we can also include the people that don't have cars with gas. and we have a total here, as well as down here. Now, we can even have a think about this little grid part here, about what maybe this one would be related to our Venn diagram, as well as this one down here. Well, the number here is the people that have, well, petrol and gas. This orange section here is like the overlap in the middle here. And the people that don't have gas or don't have petrol, that is going to be the neither section, drawn here in pink. So we can already start thinking about how many we have here. Now, and we can think about what these sections can represent. Now, my total here is going to be the 24 people. So everything along these different arrays has to add up to 24. Remember, we can't exceed that because those are just the number of cars that are tested for fuel economy. Okay, so we have 18 of these cars run on petrol. So the total cars that run on petrol are going to be 18. So I'm going to put this here. And I have the total amount of cars that run on gas. That is going to go down the bottom here. So I have 8 cars that run on gas. The total amount that run on gas. Now, I'm told that 3 of these cars run on both. Now remember, we said this section here was going to be our both petrol and gas. So I'm going to pop a 3 here. And this is where we start doing some of the similar things to the Venn diagram. Now, if there are 8 people in total who use gas, and 3 of those are both, how many run on gas but not petrol? That's just going to be the difference between my total ones and my ones that run on both. This is the same thing. This guy here represents my section, something like this on the Venn diagram. The one that is just one thing and not the other. So I have my gas here, and I'm looking for the total amount, well, the amount that have gas but not petrol. So that is going to be 5, because my ones with both, as well as my ones with gas, add up to the total cars that run on gas, which is going to be 8 here. And similarly here, we know that 3 of the ones that run on petrol run on both. But there's still a bunch of other ones in here that run on petrol but not gas. And that amount has to add with my both to give me 18. The cars that run on petrol. So remember, this total is the ones that run on petrol and gas. So if 3 of them run on gas and petrol, the one that runs on just petrol is going to be the difference between 18 and 3, which gives me just 15 there. Now, we want to find out how many run on neither petrol nor gas. Now, all the bits that I have here, so 5 represents my just gas. So maybe, let's say on a Venn diagram, it would be this part. My 3 here is the overlap, gas and petrol. So on a Venn diagram, it would be this bit here. I'm just using the Venn diagram because I find it's good for visually seeing this kind of stuff, and I've noticed a lot of students don't really like the two-way tables. They prefer the Venn diagrams. So I'll kind of jump back and forth between the others. And the ones that have not gas and only petrol, that's going to be this section up here. I know I'm using the example from the previous question, but I'm just trying to visualize it. So the amount left in here, that is what we want to find. Now, if we add up what we have so far, then I have 15 plus 5 gives me 20, plus 3 gives me 23, and I have a total of 24 cars, so only one of these is going to be not petrol and not gas. Now, these remaining sections on my two-way table, they're not as important, but they can just give us more of an idea of the spread of this particular bit of information. Because down here, we're just going to put the total of cars that don't have gas. So as we go along these tables, consider looking in the right-hand direction. My numbers 3 and 15 add to my number at the end here. As I go down, 3 plus 5 adds to give me 8. So in the same way, everything else here is kind of going to add up. That's what's useful about these types of tables. So my total amount of cars that don't have gas, so not gas and petrol, and not gas and not petrol, is going to be 16. So I'm going to pop that down here. And my total of cars that don't have petrol, that includes the ones with no petrol but gas, and no petrol, no gas, is going to be 6. And notice once again, I have a consistency here. 8 plus 16 gives me 24. 18 plus 6 also gives me 24. So the two-way table is arranged in a particular way to make it really easy to read off information. So now we've done pretty much 80% of our work. The hardest part of this stuff is making the actual table or Venn diagram. After that, everything else becomes easier. So we're asked how many of the cars do not run on gas. Well, we just have to consider this column here, the ones that don't run on gas. So this includes the ones that don't run on gas but run on petrol, and the ones that don't run on gas or petrol. This is maybe like an electric car, for example. And that total is going to be 16. So we're just reading off the diagram here. So 16 do not run on gas. Now for part 2, how many of these run on neither petrol nor gas? Well, now we just follow the columns here. No gas, no petrol. Where they overlap is this number here. So my answer there is going to be 1, the amount that run on neither petrol nor gas. And now to find the probabilities, we're considering that the probability of selecting a random car that runs on gas. So the amount that runs on gas, we take into account the total amount of cars that run on gas. So that's including the both here, ones that run on both gas and petrol, and the ones that run on gas but not petrol. So take a Venn diagram, for example. Let me actually draw one underneath here. This is where we're looking at a total thing here. This is like the total of gas. It takes into account just gas as well as the overlap. So that is going to be 8 for my answer. So my probability is going to be 8 over 24, which that can get simplified to just 1/3. Now, next bit, the probability that the randomly selected car runs only on gas. So in my Venn diagram, I'm looking at only gas, not gas and petrol. So I'm not looking at this middle section here. So the one I'm selecting here is my gas but no petrol, which gives me 5. That's going to be 5 on 24. And finally, runs on gas or petrol. So this is just the ones that run on gas, petrol, or both. So that's pretty much just everything except for the neither section here. Or, in the same way, we can, now, in our Venn diagram, this takes into account everything here. So we have gas, petrol, both, and everything except for the neither here. So I'm taking into account my gas and petrol, my petrol but not gas, my gas but not petrol. Everything except for not gas and not petrol. So if I add those all together, I get finally 23 out of 24. I also could have just taken my whole, all of the cars, so 24 out of 24, and just minused the one down here. You can do it in both ways. But hopefully this video has given you a sense of how we can break down these two-way tables and Venn diagrams, and show you that the hardest part is really constructing these types of diagrams and tables. Because once you do, these questions become a lot easier. You are just reading off the diagram. So long as your diagram's correct, it makes sense, then you shouldn't have too many more problems with questions of this sort. But that brings us to the end of the video. Thank you so much for joining me, and I will see you next time.